Good morning, everyone. In this video, I'm going to explain the MLT experiment number 7, implementation of fuzzy Siemens clustering. First, I installed the required libraries called fuzzy Siemens using pip. This library helps me perform clustering where one data point can belong to multiple clusters. And then I imported the required libraries, pandas and numpy for handling data, matplotlib for visualization, standard scaler for data normalization, Celotti score for evaluating clustering performance, and FCM for fuzzy clustering. And then I loaded the data set. I loaded my dataset using pandas read CSV function. I displayed the first few rows using head and also checked the shape of the dataset to understand how many rows and columns are present. And then I handling missing values. After loading the dataset, I checked for missing values. If any values were missing, I replaced them with the mean of the respective column using fill now. This ensures the data set is clean and ready for processing. And then standardizing the data. Next, I standardized the data set using standard scalar. This step is important because it brings all features to handle the same scale, which improves clustering accuracy. And then setting parameters. Set the parameters for the fuzzy Siemens algorithm. M is equal to 2. This is the fuzziness index. Maximum iteration is equal to 150. Maximum number of iterations. These control how the clustering algorithm behaves. And then visualizing data is in scatter plot. Before clustering, I plotted a scatter graph using the first two features of the data set. This helps me visually understand how the data is distributed. And then applying fuzzy Siemens clustering. What I did is I applied fuzzy Siemens clustering for different number of clusters from 2 to 5. For each value of k, I trained the model, predicted cluster labels, calculated the Celotti score. I stored all the scores to the compare later. Scores to compare later. And then plotting Celotti scores. What I did is next I plotted a graph between number of clusters and Celotti score. This helps me identify which clusters count gives the best result. And then finding best number of clusters. What I did is I selected the best number of clusters based on the highest Celotti score using NumPy argument of maximum, ARG of maximum. And then training final model. What I did is using the best number of clusters, I trained the final fuzzy Siemens model and predicted the cluster labels for all data points. And then visualizing clusters. What I did is I plotted the cluster data using a scatter plot. Each point is colored based on its assigned cluster, making it easy to see how data is grouped. And then finding cluster centroids. What I did is I extracted the cluster centers, means centroids, from the model and printed them. This represents the central point of each cluster. And then exporting the result. What I did is, finally, I added the cluster labels to the dataset as a new column. Then I exported the dataset as a CSV file so it can be used in tools like Tableau for visualization. Finally, I successfully implemented fuzzy Siemens clustering, evaluated the best cluster count, visualized the clusters, and exported the results. Thank you.